Morning engineering.
Morning.
So today we're from group A of the electronic circuit class. So today we're going to present about the digital stethoscope system. My name is Raidilan.
My name is Muhammad Arkan.
My name is Diane Farel.
My name is Shannon.
So today we're going to the project background. For the project background is the reason why we made this project is in the medical educational context, weak physiological sounds such as heartbeats and lung airflow are often difficult to hear clearly using the human ear alone. Okay, for next slide is the problem and proposed solution that we provide for this project is that the main problem is addressed in this project is that biological sound signals are very small in amplitude, typically in the millivolt range. And then for the proposed solution, the first amplifies the voltage of the weak signals, while the second stage provides sufficient current to drive a low impedance load by using a proper biasing and coupling techniques. Okay. For the overall circuit design, as you can see, is that it is designed as a standalone system that directly interfaces with a microphone or stethoscope sensor and produces an audible output through an 8-ohm speaker.
Okay, for the next slide, we have overall functions, which is pretty simple. The circuit itself performs low-level audio amplifications. It has two stages, which is first stage being a common emitter, voltage amplifier, and the second one being an emitter follower or a collector. Next slide. Input and biasing. The input signal represents a very weak AC, aka the heartbeat, which is indicated in this one. Resistors are used for voltage bias and all that. Next slide. For amplification stage, uses a transistor configured as a common emitter. And the second stage provides other resistors provide thermal stability, so it doesn't melt. Next stage. Then for interstage coupling, we have voltage. After the voltage amplification stage, the capacitor is used for interstage coupling. It transfers the amplified AC signal based on what data we collect. Okay, next.
Okay, so for the second amplifier, the second stage uses transistor Q2 configured as an emitter follower or common collector amplifier. Okay, next slide. And for the output and power supply, the capacitor C4 is used as an output coupling capacitor to block DC voltage from reaching the speaker and ensuring safe operation. Next. Okay. For the input process output flow, the operation of the system can be summarized using an input process output model. The input is a weak biological sound signal captured by a microphone or sensor. Next. Okay, so for the simulation,
We can just straight go to
Yes.
the real physical.
So now we can go to the 2D simulation. The 3D simulation is going to come up after this. So this is the protein simulation, as you can see. This is where the microphone comes in. We use an AC signal or an AC source in order to simulate the microphone, which goes up in a sinusoidal wave, and then it goes here, and then it goes through capacitors. It goes through like resistors over here, and then it goes through the MOSFET. Now, our MOSFET here, as you can see in this physical circuit, this is where the microphone's input source would come through from here, and then it will go through the amplifier, as you can see here. This is a non-inverting amplifier with a gain of 48, as we've calculated using the resistors. We will show you later in the project later on. And then over here, after the amplifier, it goes through the diodes over here. The reason why there's two diodes, as you can see here, for different directions. One is for negative, one is for positive. And then it goes through the BGT over here. Before that, then it goes to the LED over here. So from this whole circuit, you can tell that this part over here, it simulates the stethoscope where they take in the signals using this microphone. For example, tap, tap. As you can see, the LED lights up. This is because when you have the sound. For example, it's supposed to light up like that. So this simulates the heartbeat sensor, and we're going to do a data login later for the data here, and we're going to calculate this per time in order to calculate the heart rate per minute. So this is our project.
And to conclude this, in conclusion, the project successfully demonstrated the design, especially our proof of concept, which is a smashing success. Later on, we will show the data logging to prove this. Thank you for listening to our presentation.
Thank you.